We are given that tangent x equals negative 3 fourths and x terminates in quadrant 2, and we have to determine sine 2x, cosine 2x, and tangent 2x. So first, let's see how to determine the sine 2x. First, I have drawn this right triangle using this tangent x equals to negative 3 fourths. Also, x terminates in quadrant 2. I have constructed this right triangle with x terminating in quadrant 2. This is basically quadrant 2. Since tangent x is negative 3 fourths, I put this x, this is the angle x, and tangent x is opposite side to adjacent side according to Sokotova. This is opposite to x over adjacent to x. So therefore it is given as negative 3 fourths, and this equals opposite to x over adjacent to x. So I have marked opposite to x, that is the side AB, as 3, and then the adjacent side, which is the side OB, equals negative 4. Because in quadrant 2, this OB distance is negative, it is the negative x axis. So that's why I have marked this OB as negative 4 instead of AB. So we have this right triangle, and now we have to determine this unknown side OA. For this, we can use the Pythagorean identity. Use this Pythagorean identity to solve for the side AB. So in this right triangle, according to the Pythagorean identity, we say that OB square plus this is AB square, and this equals OA square. That is, the sum of the squares of the two legs of the right triangle equals the square of the hypotenuse. So let's replace OB, which is negative 4. This is negative 4 quantity square plus AB is positive 3. So 3 square, and this equals OA square. Now let's solve for OA square. So negative 4 square is 16, and positive 3 square is 9, and so we get OA square. 16 plus 9 is 25, and this equals OA square. So we take square root on both sides, and when we do that, square root of 25 is 5, and this equals square root of OA square is OA. So we have determined that the hypotenuse is OA, which equals 5. So I'm going to mark 5 here. Okay, so now we have determined the hypotenuse, which is 5. I'm going to find two trigonometric ratio, that is sine of x, and this equals according to Sokotova, this is opposite side, opposite to x over hypotenuse, and opposite to x is 3, so we put 3 over hypotenuse is 5, so this is 3 fifths. And let me also find cosine of x, and this equals according to Sokotova, this is adjacent to x over hypotenuse. So the adjacent side here is negative 4, and hypotenuse is 5. So we have determined these two ratios, which will help us to determine the trigonometric expressions sine 2x, cosine 2x, and tan 2x. First, let's find this sine 2x. Here we have to use the trigonometric double angle formula, that is sine 2x equals 2 sine x times cosine x. Now we have already determined the value of sine x and cosine x from 1 and 2 here. That is sine x equals 3 fifths. So let me replace sine x by 3 fifths and cosine x by negative 4 fifths. And we can simplify this. So we have to multiply the numerators. This 2 we can consider as 2 over 1. 2 times 3 is 6, and 6 times 4 is negative 24. And then we have 1 times 5 is 5, 5 times 5 is 25. So we have determined that sine 2x equals negative 24 over 25. We now determine cosine 2x. So according to double angle formula, cosine 2x equals 2 cosine squared x minus 1. In fact, there are three more formula for cosine 2x. However, I'm using this one of the formula, that is 2 cosine squared x minus 1. Now we have to replace cosine x as negative 4/5 into this formula. So I put this 2 and replace cosine x by negative 4/5. So it becomes negative 4/5 quantity square minus 1. Now let's simplify this. This becomes 2 times of negative 4/5 quantity square is negative 4 quantity square is positive 16, and we in the denominator we have 5, so 5 square is 25. So basically we get 2 times of 16 over 25 minus 1. So first let's simplify the first term. This equals 2 over 1. So 2 times 16 is 32, and 1 times 25 is 25 minus 1, and we have to simplify this fraction, so it becomes 32 over 25. To make the second one as a common denominator, multiply 1 and 1 with 25 and divide by 25, so it becomes 25 over 25. So we now have the common denominator, which means we can combine the numerators, that is 32 minus 25 over 25, and this equals 32 minus 25 is 7, so it becomes 7 over 25. So we found the value of cosine 2x equals 7 over 25. We will now determine tangent 2x. So for this, I'm going to use the quotient identity, that is tangent x equals sine x over cosine x. So using this quotient identity, I can write down tangent of 2x. This equals sine of 2x over cosine of 2x. Just replace x by 2x in this quotient identity. We get this identity, tangent 2x equals sine 2x over cosine 2x. So I write down sine 2x over cosine 2x. This is tangent 2x, and this equals, we have already determined the value of sine 2x and cosine 2x, so let's put that here. So put sine 2x as negative 24 over 25. So this is the numerator fraction, divided by the denominator we have cosine 2x, so replace it by 7 over 25. Now we can simplify this by, first let me write the numerator fraction and then multiply with the reciprocal of the denominator fraction, that is 25 over 7. See that this 25 and this 25 we can cancel, so this basically reduces to negative 24 over 7. So we have determined the value of tangent 2x, and this equals negative 24 over 7.